So today we are going to understand another problem related to inverse trigonometry, and this question is also taken from miscellaneous exercise of chapter 2. Okay, so the question is we have to prove LHS is equal to RHS, and since there are two terms in LHS and one term in RHS, so it is easy to prove with the help of LHS. Okay. In RHS 9/4 is present, that's why I try to obtain 9/4 in LHS also. That's why I take common 9/4 from these two terms, and as a result I get 9/4 bracket pi by 2 minus sin inverse 1/3. And since there is a formula sin inverse x plus cos inverse x is equal to pi by 2, and as a result, if we take this sin inverse x in RHS side, then pi by 2 minus sin inverse x will be equal to cos inverse x, and here is a similar terms pi by 2 minus sin inverse 1/3. So instead of this value we can write cos inverse 1/3, and since the formula of cos theta is equal to base by hypotenuse, so this value will be base and this value will be hypotenuse, and we can write base is equal to k because there is one hidden, and hypotenuse will be 3k, and with the help of formula we can obtain the perpendicular is equal to 2 root 2k. Okay, and again we take this value 9/4, and instead of cos inverse 1/3 we can write sin inverse, since cos theta is equal to p by h and sin theta is equal to p by h, so here we use the value of p and here the value of h. We can write this. Okay, you have to know, instead of cos inverse b by h we can write sin inverse p by h, and hence as a result we get 9/4 sin inverse 2 root 2/3 because k to k cancel out, and this is the value we have to prove in RHS. Okay, I hope you understand this.